Have you ever gazed up at the night sky and wondered, where is everybody? If so, you're not alone. This very question forms the basis of the Fermi Paradox, a cosmic puzzle that has left scientists and enthusiasts scratching their heads for decades. Now you may ask, what exactly is the Fermi Paradox? In a nutshell, it's the contradiction we face when we consider the high probability of extraterrestrial civilizations existing in our vast, seemingly infinite universe. And yet we find ourselves surrounded by a deafening silence. No signs, no signals, no evidence of their existence. It's as if we're on a never-ending quest, searching for a whisper in the cosmic winds, a hint of life beyond our pale blue dot. So, let's dive into this cosmic enigma and try to unravel the mystery of the silent universe. The Fermi Paradox stems from a simple question posed by physicist Enrico Fermi. Where is everybody? This seemingly straightforward query was born out of a casual conversation between Fermi and his colleagues in the summer of 1950. Fermi, an Italian physicist, known for his work on the development of the first nuclear reactor, was discussing the probability of intelligent extraterrestrial life with his peers. His question, though casual in nature, was deeply profound and has since sparked countless debates and discussions. Fermi's question, where is everybody, is not about a missing crowd at a party or a deserted city street. It is a question about the cosmos, about the universe teeming with billions of stars and potentially habitable planets. Given the age and vastness of the universe and the assumption that Earth is not particularly special or unique, it would be reasonable to expect that we should have had some contact with extraterrestrial civilizations by now, but the reality is, we haven't. This puzzling silence from the cosmos is what forms the crux of the Fermi Paradox. The significance of Fermi's question in the search for extraterrestrial intelligence cannot be overstated. It challenges our understanding of the universe and our place within it. It pushes us to question the notion of our uniqueness and to ponder the possibilities of intelligent life beyond Earth. It serves as a catalyst for scientific inquiry, inspiring countless studies and research into the existence of extraterrestrial civilizations. The question also carries with it a sense of existential dread. If there are indeed other advanced civilizations out there, why have they not contacted us? Are they avoiding us, or have they perished before they could reach out? Or perhaps are we alone in this vast universe? Fermi's question, simple yet profound, has sparked countless hypotheses and theories about the existence or non-existence of extraterrestrial life. It remains one of the biggest mysteries in our search for cosmic companionship, a silent question echoing through the cosmos. Where is everybody? One of the most intriguing hypotheses proposed to explain the Fermi Paradox is the concept of the Great Filter. This idea suggests that there might be a nearly insurmountable barrier, or a series of barriers, that prevent civilizations from colonizing the galaxy. But what could this barrier be? And why would it be so difficult to overcome? The Great Filter could come in many forms. Some suggest that it might be a cosmic catastrophe, such as a gamma-ray burst or a nearby supernova. These violent cosmic events could potentially wipe out any budding civilization, leaving no trace of its existence. On a long enough timeline, these astronomical calamities are nearly inevitable, and we as a civilization are not immune to them. Others propose that the Great Filter might be self-inflicted. As civilizations advance, they might develop technologies that could lead to their own destruction. Nuclear weapons, artificial intelligence, or even climate change could all potentially lead to the downfall of a civilization. Could it be that every advanced civilization is doomed to destroy itself before it reaches the stars? Then there's the possibility of technological stagnation. Perhaps the journey to becoming a spacefaring civilization is not a guaranteed outcome of technological progress. It could be that advanced civilizations reach a point of technological maturity where they no longer pursue space exploration, instead turning their focus inwards or towards other pursuits. Maybe the stars are not the final frontier after all. The Great Filter hypothesis is not without its critics. Some argue that we simply don't know enough about the universe or about life itself to make such bold predictions. Others point out that the universe is vast and ancient, and our understanding of it is still in its infancy. Could there be other, as yet unknown factors at play? Moreover, if there is a Great Filter, the question arises, have we already passed it, or is it still ahead of us? If it's in our past, then we are one of the fortunate few who managed to overcome the odds, rendering us a rare species in the cosmos. But if the Great Filter lies in our future, then our journey as a civilization might be far more precarious than we'd like to think. The Great Filter, while fascinating, is a sobering hypothesis that suggests the silence of the cosmos might be the norm rather than the exception. It forces us to confront the possibility that we might be alone in the universe, not because life is rare, but because surviving and thriving as an advanced civilization is a monumental challenge. But whether this hypothesis holds true or not, it underscores our responsibility to nurture and safeguard our civilization, as we might be among the few who have made it this far in the cosmic journey. But the Great Filter is not the only proposed explanation for the Fermi Paradox. As we continue our journey through this cosmic conundrum, let's turn our attention to alternative hypotheses that attempt to explain the silence in the cosmos. Each of these theories presents a unique perspective, with its own strengths and weaknesses, on why we have yet to make contact with extraterrestrial civilizations. Firstly, we have the rare Earth hypothesis. This theory suggests that the conditions necessary for intelligent life to arise are incredibly specific and rare in the universe. It's not merely about a planet being in the habitable zone around a star. Factors like a planet's size, its magnetic field, the presence of water, and even the right kind of star are all part of a delicate balance that might be hard to find elsewhere in the cosmos. However, with an estimated 2 trillion galaxies in the observable universe, even the rarest of conditions could occur multiple times. So, while the rare Earth hypothesis provides a compelling argument, it doesn't entirely solve the paradox. Next, let's consider the zoo hypothesis. This theory proposes that advanced extraterrestrial civilizations are aware of our existence but have chosen not to interfere, much like zookeepers with animals in a zoo. They might be observing us, studying us, or simply allowing us to evolve naturally without their intervention. The challenge with the zoo hypothesis is that it relies on the assumption that all advanced civilizations would follow the same non-interference policy, which seems unlikely given the diversity of life and culture on our own planet. Lastly, we have the idea of transcendent civilizations. This hypothesis suggests that advanced civilizations may have evolved beyond our comprehension, existing in dimensions or states of being that we simply cannot perceive or understand. They might communicate in ways that are undetectable with our current technology, or they may have abandoned physical forms altogether. The problem with this theory is that it's largely untestable. It's an intriguing thought, but without empirical evidence, it remains speculative. As we can see, each of these explanations offers a different perspective on the enigma of the Fermi Paradox. The rare Earth hypothesis emphasizes the unique conditions necessary for life. The zoo hypothesis proposes a cosmic non-interference pact, and the idea of transcendent civilizations suggests that we might not even recognize advanced life if we encountered it. These diverse explanations, each with its own merits and flaws, further highlight the complexity and uncertainty surrounding the Fermi Paradox. The Fermi Paradox is more than just a question about the existence of extraterrestrial life. It's a cascade of complexities, a web of cosmic conundrums that defy easy answers. It forces us to question our assumptions about life, civilization, and the nature of the universe itself. From Fermi's initial question, we've ventured into a labyrinth of possibilities. From the daunting Great Filter, which suggests a universe fraught with unseen dangers, to alternative theories like the rare Earth hypothesis, the zoo hypothesis, and the notion of transcendent civilizations. Each explanation opens new avenues for thought, yet each carries its own set of uncertainties. Above all, the Fermi Paradox underlines the profound mystery of our cosmic silence. As we grapple with the Fermi Paradox, we inevitably confront profound questions about our own existence, our place in the cosmos, and the nature of life itself. And so, our journey through the enigma of the Fermi Paradox comes to an end. We've traversed the farthest reaches of our understanding, delving deep into the paradox that has perplexed scientists and enthusiasts alike for decades. The apparent contradiction between the high probability of extraterrestrial civilizations existing and the lack of evidence for their existence remains a complex and engaging conundrum. Enrico Fermi's famous question, "Where is everybody?" was not merely a casual query thrown into a conversation about the possibility of extraterrestrial life. It was a profound insight, a question so simple yet so deep that it has shaped our search for extraterrestrial intelligence. The implications of Fermi's question are far-reaching, challenging our understanding of the universe and our place within it. The concept of the Great Filter, introduced as a possible solution to the Fermi Paradox, suggests an insurmountable obstacle preventing the emergence of advanced civilizations. This concept has sparked many theories, each more fascinating than the last. Could there be cosmic catastrophes wiping out civilizations before they reach a stage of advancement where they can communicate across the cosmos? Or perhaps civilizations are prone to self-destruction, a bleak prospect that forces us to reflect on our own future. Another possibility is technological stagnation, where civilizations reach a plateau in their technological development and are unable to progress further. While the Great Filter provides a sobering perspective, it is not the only explanation for the Fermi Paradox. The rare Earth hypothesis suggests that conditions suitable for life as we know it are so unique and specific that they are incredibly rare in the universe. If this is the case, it could explain the profound silence we are experiencing. The zoo hypothesis, on the other hand, posits that we are being observed by advanced civilizations, much like animals in a zoo. This explanation gives rise to a multitude of ethical and philosophical questions about our autonomy and the intentions of these hypothetical observers. The idea of transcendent civilizations suggests that advanced civilizations may have evolved beyond a point we can comprehend or detect with our current understanding and technology. This theory pushes the boundaries of our imagination and forces us to question our assumptions about the nature of life and civilization. Each of these explanations has its strengths and weaknesses, and each raises further questions. They challenge our understanding of the universe and our place within it. The Fermi Paradox is not just a scientific puzzle, it is a philosophical and existential conundrum. As we conclude this exploration, it is clear that the Fermi Paradox, with its complex web of theories and explanations, does not offer easy answers. It is a reminder of the vastness of the unknown, the humility that comes with acknowledging our limitations, and the excitement of the pursuit of knowledge. The Fermi Paradox encourages us to keep questioning, to keep exploring, and to remain curious. It is a testament to our relentless human spirit, our quest for understanding, and our insatiable curiosity about the cosmos. It is a journey, not a destination. So, as we continue to gaze up at the stars, let us ponder these profound questions. Let us appreciate the grandeur of the universe and our unique place within it. Let us continue to question, to explore, and to learn. And as we do so, let us keep alive the spirit of Enrico Fermi's question. The question that lies at the heart of our exploration of the cosmos. The question that challenges us to keep pushing the boundaries of our understanding. As we continue to gaze up at the stars, the question remains, where is everybody?